Good morning, colleagues, friends. And my presentation will mainly focus on the new understanding of climate change sciences. And you see in this figure, different colors. The gray one, you see a lot of variability there. That's representing the observed global mean surface temperature change. We say 2 degree warming, 1 degree warming, and that's the figure. So for this curve, the bars representing, because this is a monthly mean, so you see a lot of natural variability there. And the observation covered all over the world, not only on the land, but also on the surface, sea surface, and started from 1860. Because we only have the data since this period have better coverage than this period up to 1990, we call that pre-industrial level. This is proxy. And because earlier stage, they have very, very limited human activity influences. And the red color standing for all the external forcings, including human activity and the solar radiation changes, and also volcano activity. For such changes, or because of not part of the climate system, because we call that external change, so driving the change of the temperature. And the yellow one is purely human-induced, mainly by increase of the greenhouse gases, such as increase of carbon dioxide linked to the industrial revolution. And you see the increase up to the present, we have, say up to the present, we say for climate change, mainly we look at least 10 years average, because you have an year-to-year change. So 10 years change or 30 years change more stable. Then up to this period is about 0.9 degrees C increase compared with pre-industrial level. But when you look at very early, say to 2017, 2018, about 1 degree warming already. And so you see mainly the increase of temperature is induced by the human activities. And this is the curve I talked about. That's, we call that the global mean surface temperature, including land and the ocean. However, say on the land surface, above, we observe in the spring, a lot of meteorological service, we have observation, well covered on the land area, actually increased much higher than global average. So we talk about, say, about 1 degree warming compared with the pre-industrial level for the whole global average temperature. Then compared with land area, it's much higher. We can say about 2 times, compared with the ocean area. So in land area, we say we have a special report of 1.5 degrees C, but for the land area already warmer than 1.5 degrees C. And mainly for Paris Agreement of the special report, we talked about global mean temperature, not only for the land, but the land temperature increased much faster than the ocean. And not only increased the mean temperature, but you also see a lot of change with the extreme events. Especially on the land surface, you see here, increase of the heat wave, widespread floods, wildfire, and extreme sea level rise, and flash floods and heavy precipitation. And also have some small scale extreme events like tornado, and we have less confidence on this. And only some of the extreme cold extremes like frost, it's decreasing because in warming world, you have less colder extreme event. And you see, for this region, also have especially linked to the ocean changes. Global mean surface, global mean sea level is rising with acceleration in recent decades. So recent decades, the sea level increased much faster than compared with earlier period due to the increasing rates of ice loss from Greenland and the Antarctic ice sheets, as well as continued glacier mass loss and the ocean thermal expansion. Because although ocean temperature increases a little bit slower than land, but most of energy, about more than 90% of the human-induced energy in the climate system is absorbed by the ocean. So ocean is also becoming warmer and cause the thermal expansion and the sea level rise. Also, you see tropical cyclone winds and related winds and rainfall is increasing. And the increase in extreme waves combined with relative sea level rise exacerbate extreme sea level events and coastal hazards. So that's, I think, very related to the region, to the Hong Kong. And what about future? Actually, the future projection, because I already talked in the past century, mainly the change is climate change is induced by the human activity. So the future projection also based on the scenarios, based on socio-economic pathways. So one is high scenario, say in IPCC language, we call it RCP 8.5, something like business as usual. Another one is lowest scenario in CMIP 5, but this scenario is a little bit higher than 1.5, something like 1.7, 1.6, which is following Paris Agreement well below 2 degrees C, but not 1.5 yet. So you see for the marine heat wave, if based on the high emission scenario, can increase more than 10 times for the marine heat wave. If based on the lowest emission scenario, also can increase something like 5 times compared with heat wave in the earlier stage. And for the thermal expansion, you see that the heat stored in the ocean also increase very quickly and cause the thermal expansion from 0.1 to 0.3 meters. And also from cryosphere aspect, like Greenland ice sheet and Antarctic ice sheet and the glacier mass loss or increase with the scenario. And for the sea level rise, because that has very significant implication for the people live along the coast or in the island. And you see, because even we stop emission, now they still can cause the sea level rise increase based on a higher emission scenario. So up to 2,300, something like in 300-year period can increase up to more than 3 meters. Based on lowest scenario also can be about 1 meter increase. So that's a global average, not for region, not for extreme case. And also there are some other changes like decreasing of the pH value, which will cause the ocean more acidic, and the loss of oxygen, and those parts are linked to the permafrost, because permafrost is important for the mountain region, for the high latitude region, influence the infrastructure, and also if large scale thawing, it will cause more carbon greenhouse gas released to the atmosphere, cause more positive impact for the climate system. Say if we can keep temperature, we see, because Paris Agreement clearly set the target for well below 2 degrees C, and at the same time we pursue 1.5 degrees C effort. So what's the difference for only half degree temperature difference? So we look at the, because 2 degree or 1.5 degree warming is, we are referred to the whole global average. When you look at the region, actually there are large difference. Only half a degree in the polar area, you can, that much higher than 1 degree difference. So that means if we can control temperature lower, say even average temperature in the high latitude can be reduce much higher than half a degree, can up to more than 1 degree, and also can reduce, cause a lot of difference for the precipitation, and more for the extreme temperature, especially in the high, in the land area, high latitude land areas. Half degree difference can make extreme temperature difference more than 2 degrees. So that's, say, even half a degree can reduce a lot of extreme temperature change. And look at the different warming level influence on the tropical area in the Southeast Asia. Say, we can see a different color here. For hot days and nights or heat wave, say if we can keep temperature below 1.5 degrees Celsius, then you see with high confidence or the increase. But if warmer than 1.5 degrees C, that we have large increase, and over 2 degrees C will cause oppressive and very high confidence will cause the health impact, and also cause here the temperature warmer than 2 degrees will cause persistent livestock heat stress. But if we can control temperature below 1.5 degrees C, although they are still worse than today, but not as much as the high level of warming. For the Southeast Asia, you see flooding related to sea level rise. So we, for 1.5 degrees Celsius warming, we still have some risk. But if we increase more, then we have higher risks. And over than 2 degrees Celsius, we have substantial increase in risks for the flood. And for the Asian monsoon, also, say if we have a large, in a higher degree of warming, then we'll increase in precipitation intensity. And we'll substantially increase the heavy precipitation event. So that's for Southeast Asia, sea level rise, flooding, heavy precipitation will increase with the global warming level of warming. Then you see, compare with lower level of warming, say 1.5 degrees compared with 2 degree warming, we can reduce some extreme weather, especially for the people where live, and including our region. And by 2100, global mean sea level rise will be around 10 centimeters lower compared with 2 different scenarios. That also, but will continue to rise for several centuries. So limiting warming of 1.5 degrees Celsius would require a steep and a quick emission cut. So finally, I would like to show you the schematic figure here. So here, I already talked about this is human-induced warming. This is observed temperature. You see the warming trend and also have natural variability here. And up to now is about 1 degree Celsius warming. And the rate is going to continue say by about 0.2 degrees Celsius per decade. That means about in 2040 that we'll reach 1.5 degrees C if we do not take any quick, strict actions. So if we can reduce the emission and keep global carbon emission reach net zero in about 2050, at the same time, we can reduce non-CO2 agent after 2030, then we see there is about sorry, this figure. Yeah, here. There is about 2/3 of opportunity to keep temperature below 1.5 degrees Celsius. Then if we take the faster reduction, say in 2040, we can reach net zero carbon dioxide emission. At the same time, control the non-CO2 emission. Then maybe we can have higher opportunity to keep temperature below 1.5 Celsius. If we only take action to reduce the carbon dioxide, reach the net zero emission by 2050, not take action for other non-CO2 radiative forcing factors such as methane, black carbon, and other aerosol, then we only have a 50% of a chance. So that tells us, so when we're talking about, to keep, if we pursue temperature, limit temperature below 1.5 degrees C, not only should take action, immediately to reduce the carbon dioxide, at the same time, we also should take action on other non-CO2 factors. And this is the figure showing if we reach net zero by 2050, and take action earlier, then we can reach, say 1.5 degrees C, have higher possibility. And also, you can limit the cumulative carbon dioxide emission. So that means you will reduce the opportunity for overshoot. So if we higher accumulate, we have higher accumulated net CO2 emission, then we have to take the carbon dioxide in the atmosphere and store, say, under the ground, then can keep temperature to below to 1.5 degrees C. So that we have to take other measures like carbon capture and storage. I think Hansi is going to talk later on. And this showing if we do not take action for non-CO2 factors, then we'll follow this pathway. So my talk will be here. Thank you for attention.